seismic reflection and refraction methods. Various geophysical surveying methods have been and are used on land and offshore. Each of these methods measures something that is related to subsurface rocks and their geologic configurations. Rocks and minerals in the earth vary in several ways, such as density and propagation velocity. The seismic method is rather simple in concept. An energy source is used to produce seismic waves that travel through the earth to detectors of motion on land or pressure at sea. Detectors convert the motion or pressure variation to electricity that is recorded by electronic instruments. Seismic techniques are commonly used to determine site geology, stratigraphy, and rock quality. These techniques provide detailed information about subsurface layering and rock geomechanical properties using seismic acoustical waves. Reflection and refraction are the most commonly used seismic techniques. These methods determine geological structure and rock velocity by either refracting or reflecting waves of boundaries between rock units with different seismic velocity. Seismic refraction. Seismic refraction investigates the subsurface by generating arrival time and offset distance information to determine the path and velocity of the elastic disturbance in the ground. The disturbance is created by shot, hammer, or weight drop for putting energy into the ground. Detectors laid out at regular intervals measure the first arrival of the energy and its time. The data are plotted in time-distance graphs from which the velocities of the different layers and their depth can be calculated. The rays are refracted across layer boundaries where there is a difference in elastic and density properties. The critically refracted ray travels along the layer interface at the speed of the lower layer and continuously energy back to the surface to be successfully detected by the line of geophones. At some distance, the refracted ray becomes the first arrival. Shot energy is normally collected at evenly spaced interval throughout the entire length of the line in order to increase coverage and generally determine whether or not the layering is horizontal or dipping. The acquired data are computationally intense. A ray tracing computer program is used to honor all travel times and velocity, and to be able to consider a large number of layers where they present. Some applications used for seismic refraction is to investigate the depth to bedrock, groundwater exploration, and crustal structures and tectonics. Seismic reflection. Seismic reflection follows the law of mirror images. Angle of reflection from a surface is equal to the angle of incidence. Shots are fired in turn at each of the geophone position, and active geophones are added ahead of the shots and taken up from the behind of the shot. At each subsurface boundary across which the elastic and density parameter differ, a percentage of the energy in the way is reflected back to the surface where is recorded. If a particular boundary is horizontal, the reflection point will be halfway between the shot and any given geophone. Reflection boundaries are mapped out as the system rolls along. Placing each reflection point in its proper place in the subsurface requires intense and complicated processing of the collected information. And some of the application used for seismic reflection to detect subsurface cavity, for shallow stratigraphy, for hydrocarbon exploration, and for crustal structure and tectonics.